Hello everyone. Today I'm here with you all with one of the topic of class 8 maths curriculum, that is factorization. In this video we will be learning what factorization is and what all are the various methods of factorizing a given algebraic expression. So let's start. So first of all, we'll be learning what factor is. Factor is each of the numbers, it could be a constant, it could be a variable, that form a product is called the factor of the product. Like if I'm going to take an example, suppose I'm going to talk about your 2xyz. We can write this 2xyz as your 2 multiplied by your x multiplied by your y multiplied by your z. Over here 2 is a constant, your x, y, z all are your variables. When we have multiplied all these, we are getting the product your 2xyz. So we can write this product 2xyz as your multiples of your 2 multiplied by x multiplied by y multiplied by z. So this form means 2 over here, x over here, y over here, z over here are the factors of your 2xyz. So each of the numbers, it could be a constant, it could be the variable that form a product, which is forming the product, that is your 2xyz, are known as your factors of the product. So we can see over here that 2x, y, z, all these are the factors of your 2x, y, z. When we are talking about your algebraic expressions, in this case, we are not using the term your prime factors. We are not using your term your prime factors. Instead of this, we are using the term irreducible. Irreducible. So we will be saying that 2x, y, z, because it cannot be further reduced. So it is the irreducible form of your 2x, y, z. This is your irreducible form. So whenever we are talking about your algebraic expression, instead of prime factors, we are using the term your irreducible form. Now, what factorization is? Factorization means to find two or more expression whose product is equal to the given expression. When we can represent any of the given expression as the product of two or more than two expression, these expressions could be number even, these expressions could be variables even, and these expressions could be your algebraic expressions even. So if any of the given expression, we can represent this given expression as a product of your numbers or variables or the given expressions, then such type of representation is known as your factorization. We will be learning how to factorize various given expressions. So some of the methods are there of factorization. So first of the method which we'll be learning is factorization by taking out common factors. This is one of the method. So how to factorize the given expression using your taking out common factors. So first of the example over here is we have to factorize 7a square plus 14a. So what we will be doing is, first of all, we will be converting all the terms into your irreducible factors. First of all, we will be writing all the terms. Here we are having two terms. This is one of the term. This is another term. So we will be reducing these two. We will be writing these two terms as your irreducible factors. So 7a square could be written as your 7 multiplied by a multiplied by a. A square could be written as a multiplied by a. 14 could be written as your 2 multiplied by 7 is your 14 multiplied by your a. 14a could be written as 2 multiplied by 7 multiplied by a. Now what we will be doing is, this is one of the term, this is another term. We will be checking that what is common in both the two factors. Over here in this term 7 is there, and in this term also 7 is there. In this term a is there, in this term even a is there. So what we will be doing is, we will be taking whatsoever is common in both the two terms, we will be taking it out. 7 and a both are common, so we will take 7a out. Now we will be dividing this first term, that is your 7a square. 7a square we will be dividing by your whatsoever we have taken common. We have taken common your 7a. So what is remaining over here is your a is remaining. So in the bracket we will be writing your a. Now what we will be doing is, we will be dividing your 14a, the second term, by whatsoever we have taken common, by your 7a. What is remaining? 2 is remaining over here. Plus sign is there in between. So we'll be writing plus sign, and 2 we will be writing. So this is how we can represent this given expression as the product of your various expression. How we have represented this expression? As a multiple of your 2 your 7a and a plus 2. This is an expression, this is a variable, this is a constant. So we have represented this given expression as a product of your constant even, variables even, and your expression even. So whenever we are representing any of the given expression as a product of your two or more than two expressions, we are saying it to be your factorization. This is how we can factorize your 7a square plus 14a. And we can see over here we have used the law of your distributive law. Distributive law of multiplication over addition. We have how we are writing distributive law. If it is your a multiplied by b plus c, this could be written as a multiplied by b plus your a multiplied by your c. Over here a is common in both these two terms. So over here even 7a was common in both the two terms. So we have taken this a out. So we have taken 7a out and the remaining we have taken in the bracket. So we have used your distributive law and we have represented, we have taken your factorization of the given expression. Now let's see another example, that is your 5x square y minus 15xy square. So first of all we will factorize it. Both the two terms will be factorizing. So this could be written as 5 multiplied by x multiplied by x multiplied by y. 5x square y could be written as 5 multiplied by x multiplied by x multiplied by y. Now 15 could be written as your 3 multiplied by 5. Xy square could be written as x multiplied by y multiplied by y. Now in these two terms, what is common? We will be checking. 5 is common in both the two terms. X is common in both the two terms. Y is common in both the two terms. So we will take it out. 5xy. So 5xy we will be taking it out. Now if we will be dividing the first term, that is 5x square y, by your 5xy, what is remaining? X is the remaining part. So we will be writing x over here. Minus sign is here. So we will be taking minus sign. And what is remaining in your second term? 15xy square. If we will be dividing this 15xy square by your 5xy, what we will be getting? We will be getting your 3 multiplied by your y. So 3y will be remaining one. So we will be writing this algebraic expression as the product of your 5x, y and your x minus 3y. So this is how we can factorize any of the given expression by taking out common factors. Now let's understand another method of factorization, that is factorization by grouping. In this method, what we will be doing is, whatsoever the given expression is there, we will be writing all the terms in the given expression in the irreducible form. Then we will be checking whether there is a common factor in all the given terms or not. If there is not a single factor which is common in all the terms, then we will be making group of the terms. And the grouping will be done in such a way that in each group there should be some common factor. Now let's understand how we will be solving it. So first example we have taken, we have to factorize ax plus bx minus ay minus of by. First of all, what we will be doing is, we will be checking whether there is a common factor in all the four terms or not. This ax could be written as your a multiplied by x, bx could be written as b multiplied by x, ay could be written as a multiplied by y, and by could be written as your b multiplied by y. If we are going to see the factors of all the terms, we can see that there is not even a single factor which is common in all the terms. So what we will be doing is, we will be making the group of the terms. If we are making the group of these two terms and these two terms, in these two terms we can see that x is common in both the two terms, and in these two terms y is common. So we will be making the group of terms in such a way that there should be some common factor in both the terms. Now in these two terms we will be taking your x common, because in both the terms x is a common factor. So we have taken the common factor outside. Now if we will be dividing this ax by x, we will be getting your a. We have written a. If we will be dividing this b into x by your x, we will be getting b. So these two terms could be written as your x multiplied by a plus b. Now we will be doing the same for your next two terms. In these two terms, minus of y could be taken common, because y is a common factor in both the two terms, and both the two terms are negative also. So we have taken minus of y outside the bracket. Now, if we will be dividing minus ay by your minus of y, we will be getting positive a. If we will be dividing minus of by minus y, we will be getting positive b. So last two terms could be written as minus of y. In the bracket, it is your a plus b. Now we can see it is one of the term and it is one of the term. And in these two terms, a plus b is common. In these two terms, one term is this, another term is this. In these two terms, your a plus b, this is common. So we will be taking this a plus b outside. Now, if we will be dividing this term by your a plus b, we will be getting x. So we'll be writing x over here. If we will be dividing this second term by your a plus b, we will be getting minus of y. So this is how we can represent this given expression as a product of these two expressions. So whenever it is it is not possible to write all the terms, means all the terms is not having a common factor. In that case, we will be making the group of the terms, and grouping will be done in such a way that they should have a common factor. Now the common factor we will be taking it outside and we will be solving it further, and this is how we can write the given expression. One more thing is to be taken into consideration, that this bracket should be same in each and every case. Whatsoever the bracket is there, it should be same. Now let's understand another question, that is your 15xy minus 6x plus 5y minus 2. Again, we can see over here that there is not a single factor which is common in all the four terms. So we have to make the grouping in such a way that every term, that means in these two terms, suppose we are taking a group of these two and we are making a group of these two. So whatsoever the grouping we will be making, in that grouping the terms should be having some common factor. Now, if we are going to make the group of first two terms and the second two terms. So first two terms, 15xy could be written as your 3 multiplied by 5 multiplied by x multiplied by y. Minus of 6x could be written as minus of 2 multiplied by 3 multiplied by your x. Plus 5y could be written as 5 multiplied by y and minus of 2. Now in the first two terms, what is common? 3 is a common factor, x is a common factor. So 3x could be taken outside the bracket. Now, if we will be dividing 15xy by your 3x, we will be getting 5y. And if we will be dividing minus of 6x by 3x, we will be getting minus of 2. Now, in these two terms, 5 into y and this is your minus of 2. Nothing is common, so we can take 1 as common. If we will be dividing this 5y by 1, we will be getting 5y. If we will be dividing minus 2 by 1, we will be getting minus 2. So we can see over here that this bracket is same. Now, this is one of the term and this is your another term. In these two terms, 5y minus 2 is common. So we'll be taking it outside the bracket. And in the another bracket, we will be taking this. If this whole term is divided by 5y minus 2, we will be getting your 3x. And if we will divide this term by your 5y minus 2, we will be getting plus of 1. So this is how this given expression could be represented as product of these two given expression. So this is how we can factorize by your grouping method. Now let's understand another method of factorization, that is factorization using identities. So we know that if it is your a plus b whole square, this is an identity. A plus b whole square could be written as a square plus 2ab plus b square. Another identity is your a minus b whole square. A minus b whole square could be written as a square minus 2ab plus your b square. Similarly, if it is your a plus b, a minus b, this could be written as your a square minus b square. These are the identities which we will be using for your factorization. So first of all, if we are having two terms in the given expression, we are having two terms which are a perfect square. Here we can see 4p square is a perfect square, 9q square is even a perfect square, and they are having minus sign in between, then always and always we will be using this identity. That is your a square minus b square. if it is in this form, that means if we are having two terms in the given algebraic expression which both are your perfect squares and we are having a negative sign in between, then it is in the form of your a square minus b square, and this a square minus b square could be written as your a plus b, a minus b. Now we can see over here 4p square could be written as 2p whole square, because if we will be multiplying 2p into 2p, it will be your 4p square. So 4p square could be written as 2p whole square minus of 9q square could be written as 3q whole square, because 3q multiplied by 3q will be your 9q square. So over here, if we are going to compare this term, this expression by your a square minus b square, we can see value of a over here is your 2p and value of b over here is your 3q. A is your 2p and b is your 3q. So a square minus b square could be written as your a plus b, a minus b. So this could be written as your a is your 2p, a plus b, a minus b. This is how we can factorize the given expression, that is your 4p square minus 9q square as your 2p plus 3q. One of the bracket will be there and another bracket will be your 2p minus 3q. This is how we can factorize using your identity. Directly we have written it in its product of the given expression. This expression we have represented as the product of these two given expressions. Now again we can see over here that p raised to the power 4 is a perfect square, 81 is even a perfect square, and there is a negative sign in between. That means we will be using the identity a square minus b square, which could be written as your a plus b, a minus b. Now p raised to the power 4 could be written as p square whole square minus 91 could be written as 81, that is your 9 square. Square of 9 is your 81, so 81 could be written as square of 9. Now we can see over here, instead of a, it is your p square, and instead of b, it is your 9. This is your a and this is your b. So a square minus of b square. A square minus b square could be written as a plus b, a minus b. So it could be written as a plus b, a minus b. Now if we are going to see over here, again p square is a perfect square, 9 is even a perfect square. So further we can factorize it. There is no identity for your plus sign in between. Like a square plus b square, there is no such identity. So we will be keeping this bracket as it is. And p square could be written as p whole square and 9 could be written as 3 square. 9 is your square of 3. So it is your p square minus 9 could be written as p whole square minus 3 whole square. Now in this condition, your a is p and b is your 3. Now again, a square minus b square, just now we said it could be written as a plus b into a minus b. So this could be written as p square plus 9 will remain as it is. This bracket could be written as p plus 3, p minus 3. So this is the factorization of your p raised to the power 4 minus 81. This is how we can factorize it using identities. Now if we are having three terms in the given algebraic expression, we are having three terms in which first and last term are your perfect square, then we can convert it into any of these identities. It is not compulsory that it is going to be converted, but we can check it. Now we can see over here, first of all, the arrangement over here we can see 49y square. This is the first term. This is 36z square is the last term. These two terms are your perfect squares. Now whether this can be represented in your this form, a square plus 2ab plus b square, because plus sign is there in between. So it can be converted in your this form, a plus b whole square, that is a square plus 2ab plus b square. Now let's check it out. 49y square could be written as 7y whole square, because 7 into 7 will be 49. So 7y into 7y will be 49y square. Now this could be written as 2 multiplied by your 7 into y multiplied by your 6 into z. 84 we have written as 2 multiplied by 7 multiplied by 6. 6 7 is 42. 42 into 2 will be your 84. So 84 could be written as 2 into 7 into 6. and y into z. So y we have taken here, z we have taken here. So this is how 84yz could be written. Now 36z square, it could be written as 6z whole square. 6z multiplied by 6z will be your 36z square. So this is how we have written 36z square as your 6z whole square. Now if we are going to see, if we will take a as your 7y and b as your 6z. So it is your a square plus 2 into a into b plus b square, and a square plus 2ab plus b square could be written as your a plus b whole square. That means this could be written as your a plus b whole square. This is how we can factorize it directly using identity. 7y plus 6z whole square means the two brackets, it is product of your 7y plus 6z multiplied by your 7y plus 6z. It is the condition when your given expression is a perfect square. So this expression could be written as 7y plus 6z whole square. This is how we can factorize it. Now, if we are having three terms in the given algebraic expression in which first and last term are your perfect squares and the middle term is your negative, then it could be converted in your this form. That is your a minus b whole square is a square minus 2ab plus b square. Now let's check it out whether it is coming in this form or not. So here p square could be written as p whole square minus 10p could be written as minus of 2 multiplied by p multiplied by 5. 2 multiplied by 5 will be your 10 multiplied by p, 10p minus sign we have taken. Now 25 could be written as 5 whole square. Now we can see over here it is your, if a is your p and b is your 5. So it is your a square minus 2ab plus b square. It is your a square minus 2ab plus b square, and if your expression is in this form, that is your a square minus 2ab plus b square, so it could be written as your a minus b whole square. So this could be written as your a minus b whole square. So this is how using the identities we can factorize the given expressions. If it is in these form, if there are two terms and both the two terms are perfect square and there is negative sign in between, then you will be using this identity. If we are having three terms in which first and last term are your perfect squares and positive sign is there in between, then it could be in the form of your a plus b whole square is equals to a square plus 2ab plus b square. We have to check whether the middle term is in the form of your 2ab or not. If we are having three terms in which first and last term is perfect square and the middle term is your negative, then it could be written in this form, that is a minus b whole square is your a square minus 2ab plus b square. So this is how we can factorize the given your algebraic expression by various methods. There is one more method in which we can factorize the given trinomial by middle term splitting method. So we are already having a video, separate video for how we can factorize the given polynomial or given trinomial basically in which there are three terms using your middle term splitting. If there are three terms and they are not coming under these categories, means they are not perfect square, then how we can factorize it by middle term splitting, we are already having a video on it. So this is all from this chapter. Soon we will be coming with more videos on other topics of class 8 maths curriculum. Hope it is clear to you how to factorize a given algebraic expression. Thank you.